Howdy! Today we will review the SI and the English units and properties such as specific volume, pressure, and temperature. And these concepts we learned in chapter 1 will be used in the following chapters. It is very important to have a good understanding of the concepts. So pressure, volume, and temperature can be easily measured. And this property will be used to determine the other thermodynamic property of a system, such as internal energy, enthalpy, and entropy we will study later in the semester. So today we cover 1.4 to 1.7. Let's get started with 1.4, measuring mass, length, time, and forces. So in thermodynamics, we deal with different forms of energy: kinetic energy, potential energy, mechanical work, electrical energy, and internal energy. So it is important to use consistent units. In other words, every term in an equation must have the same unit. So let's see units of mass, length, and time. So International System of Units, or SI unit, for mass is kilogram. The unit of length is meter. The unit of time is second. The SI unit is also called the metric system. It is a decimal-based system of measurement units. The English system is used in the US, and it is confusing and difficult to learn. But it is still widely used in the US. So in this class, we will use both English units and SI units. The English units of mass is pound mass. So sometimes we write lb, m. So m stands for mass. So 1 pound mass equals 0.45359 kilogram. Length is foot. 1 foot equals 12 inches or 0.3048. 1 foot is 0.3048 meter. Time is second. The SI unit of force is Newton, and Newton's second law of motion states that 1 Newton is the force that will accelerate a mass of 1 kilogram by 1 meter per second squared. So 1 Newton equals 1 kilogram times meter per second squared. So it can be also written 1 Newton divided by 1 kilogram times meter per second squared equals 1. So this will be often used for unit conversion. The English unit of force is pound force. So 1 pound force. So here you see F denotes force. So 1 pound force is the force that will accelerate 1 pound of mass. Here lbm, or just simply lb. So that will accelerate 1 pound of mass by 32.174 feet per second squared. So why we use this 32.1740? It is the gravitational acceleration. Or you may interpret it as 1 pound force equals the force that will accelerate 32.1740 pound mass by 1 feet per second squared. And gravitational acceleration 32.1740 feet per second squared equals 9.807 meter per second squared in SI unit. So 1 pound force divided by 32.1740 pound force pound mass times feet per second squared equals 1. Also, this will be used for the unit conversion. Let's see an example. So determine the weight of an object whose mass is 1000 pounds. So mass is 1000 pounds. So this LB M is a mass at the location where the local acceleration of gravity is 32 feet per second squared. So force is MA, or here G, gravitational acceleration. So M times mass times gravitational acceleration. But this LB is the unit of mass. But we need to calculate weight, which is force. M times acceleration, gravitational acceleration. So we need to convert this pound mass to pound force. So use this unit conversion. 1 pound force divided by 32.1740 pound mass feet per second squared. This is equals 1. So F is calculated in terms of pound force.